Okay, class, we're 3.6. Stuart, here's Michelle for you.
Hi, Stuart. I love you and miss you. Come back soon.
Okay, there you go, Stuart. I don't know if everybody else feels that way. I'm taking a poll right now in class. They're not paying attention. So we'll get started here. Okay, you guys, I want to do problem C and D. This is going to take us a little while. I'm going to do this on the back side so I have a little bit more room. 3x minus 5 to the fourth. Shh. Boys and girls. Okay, what we're doing with today is, again, we've tried some of the easier problems. Yesterday in class we looked at the worksheet that had all the problems of the chain rule, and we were able to make sure that people did them correctly. Today we're looking at if you have multiple components. So here we have two rules that we're going to apply. Number one would be the chain rule, and number two would be the quotient rule. Okay, so I have a top function and I have a bottom function. And so when you take the derivative, you do the derivative of the top times the bottom left alone times the derivative of the bottom minus the derivative of the bottom times the top left alone divided by the bottom squared. So what's that? You don't. If you wanted to, I'm going to in this situation, but if you wanted to write it like this, 3x minus 5 to the fourth times 2 minus x to the negative sixth. So technically you can always write things as the product rule and the chain rule. I'm not, or do you want to do that? Okay, let's do the quotient rule regularly. Okay, so here's how I'm going to divide this up. I'm gonna identify two functions. I'm going to call them we'll call them w and v. Okay. The w of x we'll call is 3x minus 5 to the fourth. And we'll call v of x is equal to 2 minus x to the sixth. Now, most of this rule is pretty simple to carry through the quotient rule when I leave stuff alone. But when I take the derivatives, that's where it gets a little tricky. So I'm just going to perform the quotient rule twice, or the chain rule twice, so I can actually see what those derivatives are. So I'll set this up just like you guys have all of your other problems. That'll be w of u and u of x. W prime of u and u prime of x. Then over here, v of u, u of x, v prime of u, and u prime of x. The notation of u will be used throughout calculus, including second semester. U always is identified as the variable for substitution purposes. Thus, u for substitution. So, okay. So, what is w of u in this situation? U to the fourth. Very good. What's u of x? 3x minus 5. So u prime, or w prime would be 4u to the third, and u prime would be, so I have to remember to substitute back in. So I would have 12 times 3x minus 5 to the third power. So that would be that derivative. Okay? I'll do this one now. What's v of u? U to the sixth. What's u of x? 2 minus x. What's v prime of u? 6u to the fifth, and u prime of x, negative 1. When I multiply these together, I get a negative 6. Remember to substitute that back in, times 2 minus x quantity to the fifth power. So I have my two derivatives. I'm now ready to use the quotient rule. F prime of x will be equal to, what's the derivative of the top? Times the bottom left alone. 2 minus x, quantity to the sixth, minus the derivative of the bottom, times the top left alone, which is 3x minus 5 to the fourth, all over 2 minus x to the 12th. What do you guys think? Now, I'm not going to ask you to multiply this all out, but there is something interesting that we could do here that isn't going to be all that much work. Do you see something that is carried in the top that is also in the denominator? 2 minus x's. So watch what I'm going to do here. I'm going to erase this bottom portion so I give myself a little bit of room. And if what is the common factor I could take out? 2 minus x to the fifth. If I take out, sorry. If I take out a 2 minus x to the fifth, what am I left with here? 12 times 3x minus 5 to the third times 2 minus x. What am I left with here? Plus 6 times 3x minus 5 to the fourth. So I took that out, and it will divide with the 2 minus x to the 12th on the bottom. How many will cancel off? 5 on top will cancel off with 5 on the bottom, which will leave us with 7. So therefore, your true answer is 12 times 3x minus 5 to the third times 2 minus x plus 6 times 3x minus 5 to the fourth, all over 2 minus x quantity to the seventh power. Questions? Oh, this 2 minus x? Oh, I can't get rid of this 2 minus x because, note, I have. So the question is, why can't I get rid of the 2 minus x right there in the middle? That's one term. That's another term. And in order to divide it off, I would have to divide from each spot. And that one doesn't have any anymore. I just took out the 2 minus x to the fifth and divide those 5 off with 5 more on the bottom to give 7 in the denominator. Yeah? Okay. Difficult problem. Here's what I would expect, everybody. If I said find an equation for a line tangent, I wouldn't expect you to necessarily reduce this entire thing on a test, but I do expect you to be able to come up with a derivative that you could then apply. Now, this is pretty messy, but if you get something that's going to be messy like I did on the last test, you got to be able to put it to use. So I'm not concerned that we can necessarily reduce everything algebraically, but we need to be able to move somewhere. So let's do one more on that sheet, then we'll be done with that. We have negative 8 sine to the fourth of 4x minus 2. Aaron, can you read that off again for me? Negative 8. Negative 8 or negative 8x? Just negative 8? Oh, that makes it easier. Okay. This is a really really good problem, and the reason why is it involves two things. Can anybody see the two things it involves? Not the product rule. Chain rule. How many times? 4? No, 4. That would be horrible. I don't think I've ever done that. I've done it 3 times, but not 4. This involves twice. Let me show you. We can rewrite this as follows. This is going to be f of x is equal to -8. And if it's signed to the fourth, the way that we understand that is this. Sine of 4x minus 2, that whole sine thing to the 4th power. So that's how we understand that. And so now we're going to start working with it. I'm going to identify an outside function and an inside function. So I'm going to set it up just like I would a normal chain rule, and you'll see where the double piece comes into effect. So here's the first piece. I will have f of x, f of u. I will have u of x, f prime of u, and u prime of x. Now, can anybody identify f of u? Very good. -8 u to the 4th. So we're going to call that whole thing on the inside. We're going to call that whole thing on the inside my inside function. So that'll make u of x what? Okay. What's the derivative of f of u? -32 u to the 3rd. And what is the derivative of u of x? We must use the chain rule again. Look here, you guys. You have a function that sits inside a function. So let's make some quick work of that. What's the outside function here? Sine of u. What's the inside function? 4x minus 2. What's the derivative of the outside? Cosine of u. What's the derivative of the inside? 4. So therefore we get 4 cosine of 4x minus 2. So note I had to do a chain rule a second time, and that's why we practiced it on Monday, was that, it gave you guys ample practice to try 20 problems that most of them went pretty quick, so you could get really good at doing this, so if you had to do it a second time, you could. Now, I was telling the people on Wednesday that were here that I don't always cover this level of difficulty with everybody, but trust me that, you guys are, number one, you're smart enough to handle it. Number two, you'll be thankful when you get to college and you've done harder problems like this, that for those of you taking Calc 2 or even Calc 1 over again, it'll go quite well. I think it was Chris Stahl I was hearing from that he took Calc 2 or he took Calc over, and he said it's so much easier the second time around, and he's glad he's learning it even better. And he said in comparison to the other kids, he said he's just flying through it. So I think that's what I heard. Yeah. So we can put this back in here now. We got u prime of x is 4 cosine of 4x minus 2. So now, being I did the chain rule twice, I have the pieces that I need. I will take these two and I'll multiply them together, and I have to put this back on the inside there. So, yes. Yes. No. So we're going to take that and plug it back in, and then I got to multiply these two together. What's -32 times 4? -128. This thing to the 3rd power. times my cosine of 4x minus 2. So it really wasn't that bad, but it does involve using that rule twice. Okay? And then I think we have one last problem on the backside that's it's actually a pretty short problem. I'll pause here for a second. Right, we just had one problem on the backside. Yeah, that problem won't be any issue at all. Okay, I can move past. Yes. Okay, example 5, find the equation for the line tangent to the curve at the given point. Again, remember we started doing these basically on the first day, second day, but they were, much easier. Now we have a 2x minus 3 to the 5th power. I don't necessarily know exactly what that looks like. We'll graph it on our calculator in a minute. But in order to write an equation for a line, what two things do I need? A point on the line, which is 1, negative 1. That's already identified for us. And then I need my slope. How do I find my slope? Take the derivative using the chain rule and plug in your x value to find the slope. So I will just identify f prime of x, which happens to be in this case. If you want to work it out, we would say u to the 5th, 2x minus 3, 5u to the 4th, 2. So we have 10 times 2x minus 3 to the 4th. Is that correct? So that would be my derivative using the chain rule. Now, in order to find the slope, what do? I plug in 1. So 1 times 2 is 2, minus 3 is negative 1. What's negative 1 to the 4th? 1 times 10, 10. My slope is 10. What do you want to do next? Y equals mx plus b. What is your y value? M is 10. X is 1. Negative 11 is equal to b. So y equals 10x minus 11. If we graph that, I'm very confident that it will match tangent at that point as well. You already graphed it? Very good. Sammy has confirmed it for us. That brings us to that end. I will, you have most of your assignment. There's just a couple problems like this one that I need to add to that. Taylor, why don't you give a shout out to Stuart? Say bye.
Bye.
Later, bud.